Alright, here are quiz 4 solutions for Math 251. In the first problem, we're given 3 different functions and asked to find their derivative. I think we'll have to use the chain rule, or at least it'll be easiest to use the chain rule for all 3 of these. For the first one, trying to find f prime of x. And I think it'll make it a little bit easier if we think about the derivative we're having to take as this product, x times sine of x, all raised up to the 1/3 power, as opposed to the cubed root of, because then it's a little bit easier to see the chain rule in there. In fact, maybe I'll even color code it. The 1/3, specifically x raised up to the 1/3 power, is kind of our outermost function. So when we want to find the derivative, what we do is we use the power rule, taking care of this 1/3 here. You bring that down in front. And then if we subtract 1 from 1/3, we're left with negative 2/3. What makes the chain rule a little bit different is it's not x raised up to the negative 2/3, it's whatever the inner function is raised up to the negative 2/3. So in this case, x times sine of x. And then you're not done here. We've only taken the derivative of the outer function. We still have to take the derivative of the inner function. So we're going to multiply this by the derivative of x sine of x. So we've managed to rewrite this in a way where this part's all done. There's no more derivatives left here. So we have 1/3 x sine of x to the negative 2/3 power times, and now we just got to figure out this derivative. We can figure out this derivative, we're completely done. And this derivative, we'll have to use the product rule. Should I show that? I guess I can show it. So the derivative of the first function times the second function plus the derivative of the second function times the first function. Make sure you put these parentheses on the outside because we want this first term to get multiplied by all this stuff, not just the stuff before the addition sign. Alright, so now if we figure out these derivatives, we're all done. So this we've been done with for a while. Derivative of x is just 1. 1 times sine of x is just sine of x. And then to that we want to add the derivative of sine is cosine. And then we multiply that by x. So what we're left with over here is x cosine of x. And that's final answer. Different ways you can rewrite this. But I don't even think I'll bother rewriting it. I think that's a perfectly good answer. We'll leave it as that. Second problem. Alright, we want to find the derivative of, actually there's a couple different ways you can do this problem. So maybe I'll label them. I think the more obvious way to do it is just to say, okay, g prime of x is the derivative of this entire thing. But what I have here is kind of an outside function, which is x raised up to the 5th power, and an inside function, this x squared plus x minus 2 divided by x plus 2. So if I use the chain rule, I want to first take the derivative of the stuff in blue. Something raised up to the 5th power, its derivative is 5 times that something raised up to the 4th power. So on the inside of these parentheses, I'll just leave x squared plus x minus 2 over x plus 2. But then you're not done. You still have to multiply that by the derivative of the inside function, in this case x squared plus x minus 2 divided by x plus 2. So our final answer, this is all done. But we still have to get our final answer, we have to take the derivative of this quotient over here. Take the derivative of this quotient. One way to do it is using the quotient rule. So the derivative of the top, yeah, I guess I can write that out. The derivative of x squared plus x minus 2 times the bottom minus the derivative of the bottom times the top. And don't forget that all gets divided by the bottom function x plus 2 squared. So if I take these derivatives, what I'm left with is 5 x squared plus x minus 2 over x plus 2 to the 4th times, make sure you put in parentheses here, otherwise this will only get multiplied by the first term. The derivative of x squared plus x minus 2 is 2x plus 1. 2x plus 1 gets multiplied by x plus 2. And from that we want to subtract this derivative. Derivative of x is just 1, derivative of 2 is 0. So this is all just equal to 1 here, times x squared plus x minus 2 all over x plus 2 squared. This can simplify, but I don't really care if you simplify, so I'm going to leave it just like this. Perfectly good final answer. Another way you can do this problem, maybe we'll call it option 2. I can change the color here. And the trick for option 2 is noticing that x squared plus x minus 2 is equal to x plus 2 times x minus 1 if you factor this guy out. So what we really get is that g prime of x is just the derivative of, how should I write this? All right, I'll write it all out. Well, no, I won't. X minus 1 raised up to the 5th power. Just x minus 1 inside these parentheses because the top here is x plus 2 times x minus 1. And the bottom I got x plus 2, so I cancel out those x plus 2s. I'm left with just x minus 1 to the 5th power. This is an easier derivative to take. We're still going to use the chain rule. For the chain rule, we'll first take care of the outside function, 5. Leave the inside function alone, raise it up to the 4th power. And then multiply that by the derivative of the inside function, x minus 1. The nice thing is that the derivative of the inside function in this case is just 1. So what we get for our final answer is it's just 5 times x minus 1 to the 4th power. So either of those work out fine for your final answer. This would all simplify to this if we took the time to do all the algebra. All right, third one. So we want to take the derivative of this thing. First, I guess you can notice you have two terms. So the derivative of a sum is just the sum of the derivatives. So what I want to do is take the derivative of what I have over on this side, which is the cosine of, maybe I'll color code these, cosine of 2x to the 5th plus 3x squared minus 7. And then that entire thing squared. So really we have three functions. The outermost function is this entire thing squared. The second level is cosine of something. And the innermost level is this polynomial here in blue. Then I want to add to that the derivative of, again I'm going to need chain rule, cosine of something, in this case x squared. So really the hardest part about this problem is just kind of seeing all the different functions inside functions. If you can do all that, we can just start applying the chain rule. Our outermost function here is this squared. So what we're going to do is move that 2 down in front and leave all this stuff alone. 2x to the 5th plus 3x squared minus 7. And now that's to the 1 power. But then we're not done. We still have to multiply that by the derivative of the cosine of 2x to the 5th plus 3x squared minus 7. So this part's all done. 2 cosine of 2x to the 5th plus 3x squared minus 7. And then for this derivative here, the outermost function is cosine. Derivative of cosine of something is negative sine. And now we can leave all of this alone, this inner function, 3x squared minus 7. Then we're not done. We have to multiply that by the derivative of 2x to the 5th plus 3x squared minus 7. And note all of this is just for this first term here. So really to make all these lines correct, I should say. And then I'll still have to take the derivative of cosine of x squared. All right, getting closer to the end here. This is all done. All that's left is to take the derivative of this polynomial, which isn't too bad. Using the power rule, I get 10x to the fourth plus 6x to the 1 power. And then over here, I want to take the derivative of cosine of x squared. All right, the derivative, well, I guess I can just write that. The derivative of cosine is negative sine. So I got negative sine of something. X squared is my inner function in this case. Maybe I need to change colors again to emphasize that. And I'm not done. I have to multiply that by the derivative of x squared. Now I'm finally done. We copy this whole thing. I get the derivative of this second term is this guy. Whew. So that's quite a problem. But this entire mess down here would be your final answer.